Respected sir, today myself Ashvin Sudarsan,
And I am Athul Sankar.
we are here to present our seminar on the topic micro-manufacturing. Micro-manufacturing is a process which produces small fine substrate surfaces. These types of methods create both mechanical and electronic elements, which is used for various types of microfabrications and even in microscopic devices. Micro manufacturing concerns different types of manufacturing methods, different types of technologies, different equipments, different strategies, and different systems for manufacturing of products. Micro manufacturing is something which is in between nano manufacturing and macro manufacturing. Even micro manufacturing is also sometimes categorized as silicon based manufacturing and non silicon based manufacturing. Talking about the advantages of micro manufacturing, first will be the material cost is really less. Material loss is really less. Then micro manufacturing provides higher stability. They provide good mechanical properties and higher dimension controls. Disadvantages include higher fabrication steps which is involved and which can hence be expensive. Then the technology which is used is not simple compared to other types which will be complex and sometimes it will be difficult to use for the larger structures. Applications. There are various applications for micro manufacturing starting with welding. Different types of weldings are used, different types of electronic connectors, accelerometers, microfluidic valves, particle filters, probes, 3D machine, and many more. There are several types of micro manufacturing. Depends on the type, depends on mass containing, depends on subtractive, additive, nano finishing, joining. So mainly there are micro turning, micro milling, micro casting, micro molding, micro soldering, micro welding, and lapping, and there are various types of micro manufacturing. We'll be going in detail of some of them. Micro turning. So here we are going to talk about the characteristics and its applications. They use ultra precision lathes for diamond turning and miniature desktop machines are used. The maximum machining diameter is 7 millimeter and the maximum machining length is 40 millimeters. Uh, Special tool system is used for this type of micro manufacturing. Here, as you can see, this diagram consists of a clamping unit and a cutting unit. So the basic operation will be, as you can see in the number, as you can see which is listed on the right side, the raw material is the first number one. Number two will be the straightening unit, as you can see in the diagram. The third will be the longitudinal feed drive in which the feed is provided. 4 will be the supporting sleeve which supports the system. 5 is the cutting tool which is used to cut. And 6 is the rotating tool head which rotates about an axis. The machine uptime is reduced to 20 to 25 to 40%. Micro drilling. Micro drilling is a term which is used to describe drilling of holes which is mainly smaller than 3 millimeters in diameter. And for this micro drilling requires a very sensitive machine which is precise tools. Applications include inkjet printers. There are advantages and disadvantages of micro drilling. Advantages are listed like materials, plastics can be composites can be drilled, and the higher controllability of micro drilling. Disadvantages include inclination of holes, and sometimes it can be the materials can be brittle and hard materials break into micro drills. Diameter range around 0.12 millimeter to 2.8 millimeter. The length is 10 millimeter with the shank. This drilling is used for aircraft, titanium, stainless steel, etc. So you can see in this video, this is the micro drilling process, which a 0.3 micromillimeter driller is used.
So next topic is micro molding. Micromolding is a highly specialized manufacturing process which produces extremely small and high precision thermoplastic parts and also produces some micron tolerances. This process starts in a tooling department in which a mold is created which contains a cavity in a desired shape. Here, thermoplastic is rapidly injected into a cavity, creating a component or a part at a higher speed rate. So, these micromolding contains certain features, which include the first feature is part weight. The part weight ranges from 0.001 to zero point 0.1 gram, and the part size is of 0.1 millimeter. It also contains certain specialized machines. The tooling is very intricate and also contains a specialized part extraction. Now there are two types of molding. The first one is injection compression molding and the second one is reaction injection molding. Now, this is the flow chart for injection molding process. The first one is plasticization. The next one clamping followed by filling. Then after filling there is a changeover in the position. Then it undergoes packing followed by cooling. Then the demolding process. Then the last step is ejecting. Then after ejecting, some of the parts will again undergo clamping followed by the same cycle, that is filling, packing, cooling, demolding and ejecting. Now we will have a detailed study of the micromold design. The demolding includes wear and tear of mold inserts. The next is the inclination angle. That is the inclination angle of 2 degree reduces these demolding forces and it also reduces the roughness of side walls. Then these demolding forces include shrinkage of polymers. Then these delicate microstructures are protected against shearing forces which results from the shrinkage and mold filling by some auxiliary structures that are stable or which have the ability to withstand these forces. So if a mold is covered with certain microstructures of different height or varying density, then these areas should be arranged symmetrically on a mold insert. So in the above ways we can avoid the tightening of the mold. Now we will have a detailed look about the micromolding tools. These microstructure contains a mold insert and tools. Now we have certain requirements for these mold inserts, which include friction on side walls, then small inclination angle. Then we have tools and injection system for metal processing. It includes mechanical micromachining, laser structuring, EDM, and lithography, which include X-rays and UV rays. Now, the applications of micromolding. These micromolding have been used in different fields of industries. In automotive, they are mainly used in microswitches and connectors. In computer, they are mainly used for connectors, printer, inkheads, etc. Next, in telecommunication, these are mainly used for fiber optics and connectors. In electronic, they include microparts. In medical applications, it includes hearing aid and implants. In sensors, it mainly includes airbags and sensors. In micromechanics, it includes micro engine and the rotators. In optics, it is used for lenses and displays. In watch industry, it is mainly used for micro gears and cog wheel. For GF transmission, they are mainly used in connectors. Then in institute and university, it is mainly used in technology and material trials. Now we'll have a look of the limitations of the micromolding. It includes structures of only few tens of nanometer in size. Then it have limitations in achieving high aspect ratio. Then for demolding there are certain limitations for certain structures. Then the FEM calculations are only for mold filling, but recently we have found that FEM calculation for demolding are available. Now we'll have a detailed look of the future scope of micro manufacturing. So to generate more significant impact in our industry and a people's life, Micro manufacturing will have to be better linked to macro manufacturing and nano manufacturing. So, micro or nano wear and damage of micro manufacturing tools needs to be studied more and more, and the knowledge should be transferred to the design fabrication, especially for the surface treatment of tools. Now, micro manufacturing research and development should not only focus on small things, but also should serve as a vehicle to drive traditional manufacturing towards better quality and by providing higher efficiency. Another goal of micro manufacturing is the production of certain products using miniatured systems, that is, usage of large sized machines. Thank you.
So we both ourselves end this presentation. Thank you for your patience.